गोकुळ पूर्ण मीटिंग रेकॉर्ड करा.
हो सर.
ओके, थँक्यू.
Okay.
Good afternoon all. My name is Dr. Vikram Uttam Pandit. I am PG coordinator. At HV Desai College, Pune, and we are here for international webinar on high value development in chemistry. Today we have with us Vice Principal of our college, Dr. Anita Sathe ma'am. Resource person for today's webinar, Dalila Hammiche ma'am. I, along with Vaishnavi ma'am and Dhanasri ma'am, welcome you all for this webinar. Now I request Dr. Anita Sathe ma'am, please guide us.
Hello everyone. Just give me a few seconds. I'm getting down from the cab. Just hold on, please. Okay, thank you. It's nice to see you all here, and it's a great opportunity for you to interact with you because you all are scientists getting together here for a high valued chemical developments. As I come from commerce stream, initially I thought, what do I talk about chemistry? I have left it in standard 10th only. But then I thought of sharing some of the incidences which in everyday life which I come across. Like when I enter my house, my gate is made of iron, and specifically in rainy season it rusts. So then why it rusts? Chemical reaction, isn't it? I'm working in the kitchen, I'm cutting an onion, and my eyes they start shedding water. Why it happens? Again chemical reaction. I'm cutting onion, and then I have a very small cut on my hand. I apply haldi and the blood flow stops. Why it stops? Again chemical reaction. So every day I'm coming across chemical reactions, and someone is controlling these reactions for my body. So who is it? As you all know, it's ultimately brain. Our brain, it secretes very important chemicals called as neurotransmitters. Brain secretes dopamine. When we are doing any activity which we like, which gives us pleasure, this dopamine is secreted and it is responsible for our movement and motivation. If there is imbalance of this dopamine, then we lack in motivation. Brain also secretes serotonin, and this serotonin is secreted when we do any activity with integrity, sincerity, and we get the feeling of satisfaction. There are two important chemicals known as oxytocin, okay, which is secreted by pituitary gland, and it produces the feeling of love and connection. And ultimately, there are endorphins, okay, which trigger positive feeling in us, like greeting others, laughing, sharing some great news, and so on. So then I thought I should share this with you because, see, the end result is the positive chemical, high valued chemical developments. This is the end result. This is the attitude. But why this outcome? Why the outcome is so efficient? Have a journey inward. If a person is balanced by his mind and body, if the chemicals flow in a proper way, the chemicals I have just listed out, you will be a balanced person. And if you are balanced inwardly, only then the outward results they are going to be very efficient. Isn't it? I think all of you will agree with this. Therefore, one has to be balanced. So, what do we do? Just think, do we eat balanced food? Yes, we do. Do we exercise? Yes, sometimes. And do we meditate? For the highest quality of dopamine, serotonin, and the all other neurotransmitters, do we meditate? No, maybe it's once in a month, once in 6 months. So I just wanted to share with you all these things. That is because for the outward journey, you need to be balanced inwardly. And therefore, if we are lacking in making efforts for this inward journey to keep flow of these chemicals in a proper way, then outcome will not be very good. So I just wanted to share with you all these points and just think over it for a very efficient outward outcome that you are looking for. So thank you very much and good luck to you all. Oh, over to Pandit sir.
Vaishnavi ma'am.
Yes, sir. Thank you, Sathe ma'am, for this wonderful talk and explaining the connection between chemistry and life in a very short time, but very nicely. Today, we have a very honorable guest with us, Professor Dalila Hammiche ma'am. Yes, is there any problem?
No, no. Good morning. I am listening.
Okay, ma'am. uh, so I find immense pleasure in introducing our today's honorable chief guest, Professor Dalila Hammiche ma'am. She is working at Laboratory of Advanced Polymeric Materials, Faculty of Technology, Department of Processing Engineering at University of Algeria. Madam has done research in different fields. Her research interests are aspects of processing and structure property relationship of polymer composites, then composite interfaces, thermoplastic composites and nanocomposites, development of eco-composites, bio-based composites and recyclable all polymer composites, natural fiber composites, nanocomposites, biopolymers, nanoclay, cellulose and cellulose nanoviscers, etc. She has published more than 60 indexed publications, 3 books, 2 book chapters at Nova Science Publishers and elsewhere. She is a reviewer of different national and international journals such as Journal of Polymers and the Environment, SN Applied Sciences, Journal of Construction and Building Materials elsewhere, Intercontinental Journal of Bioagricultural Sciences, that is IGBA, World Journal of Engineering and Physical Sciences, WJEPS, Industrial and Engineering Chemistry Research, and many more journals. With this brief introduction, I request Dalila ma'am, please guide us. Ma'am, can you hear us?
Hello, Dalila ma'am, start your presentation.
Yeah. That's
Vaishnavi ma'am, please also please take the attendance.
Is it visible?
Yeah, it's visible.
Okay. Good morning, everyone. I would like firstly to thank everyone for coming to this event today and welcome. And it is an honor and with pleasure to have the opportunity to take a side in this meeting. I also want to say thank you so much, Dr. Vikram Pandit, and your principal of your college to invite me. Today I am going to talk about biopolymer chemistry. So let's start with short introduction. Plastic is the term commonly used to describe a wide range of synthetic materials that are used in a huge and growing range of applications. Indeed, everywhere you look, you will find plastics. We use plastic products to help make our lives cleaner, easier, safer, and more enjoyable. We find plastic in the clothes we wear, the houses we live in, and the cars we travel in, the toys we play with, the screen we watch, and medical equipment we benefit from all contain plastics. So plastics has become somewhat misguided way to describe polymers. Also, we can say plastic have displaced other materials as that were previously used for the applications. That plastic now dominates, such as wood, metal, and glass. Indeed, if it is shown in this figure, we have this table at the left, which is made from metal, glass, and wood. But we can get beautiful with nice design another table with another material, which is the plastic. So here I want to say that plastic can displace really the all materials such as metal, glass, and wood. So the incredible versatility of this group of materials accounts for the continued growth in production year after year. In tandem with that growth, the market value of plastic also continued to grow. As we can see on this figure, global plastic production totaled 368 million metric tons in 2019. It is estimated that production in 2020 decreased by roughly 0.3% due to the COVID-19 impact on the industry. But I think there will be an increase in the production and the use of these materials very soon. Let's give a short or a simple definition of polymers. Plastics consist of long molecule chains known as polymers, created by linking the same repeated bonding elements, which is called monomer. Synthetically produced plastics are made from mineral oil, coal, or rubber gas, or natural gas. A total of 4% of the worldwide production of oil and gas is designated for the manufacture of plastics. The study of such materials lies within the domain of polymer chemistry. And the investigation of natural polymers overlaps considerably with biochemistry. But the synthesis of new polymers, the investigation of polymerization process, and the characterization of the structure and properties of polymers materials all pose unique problems for polymer chemists. Polymer production is one of the most important areas of applied chemistry due to its significant economic and social impact. So, commercial polymers are formed through chemical reaction in large vessels under heat and pressure. Indeed, we need two conditions in order to make the polymerization, which is the heat or the temperature and the pressure. When we obtain polymer, sometimes we need to add some ingredients which are called additives. which are added to control how the polymer is formed and to produce the proper molecular length and desired properties. This chemical process is called polymerization. So, as we can see under this on this figure, synthetic polymers are produced in different type of reactions. Many simple hydrocarbons, such as, for example, ethylene or propylene, can be transformed into polymers by adding one monomer after another to growing chain. Here I give you one example, which is the PVC or polyvinyl chloride, which is one of the most widely used polymers in the world. For example, it is used as pipes to conduct the water. So PVC is produced by polymerization of the vinyl chloride monomer. And we call this polymer homopolymer. Why? Because sometimes we need only one monomer to synthesize or to polymerize polymer, and we obtain homopolymer. But when we use two monomers, we obtain another type of polymer, which is called copolymer. So in the case of PVC, we use only one monomer, which is the vinyl chloride unit, and we obtain homopolymer. This polymer is generally rigid. That's why we have to add some ingredients or additives such as stabilizer. Why? In order to improve the thermal properties of this polymer. And also, as I said, it is a rigid polymer. That's why we have to add plasticizers. Like this, we can find many applications for this polymer. Using synthetic polymers, we are faced of two problems. The first one is the oil production. In that, oil production in 2025, tight oil production is 4% lower than 22 in the high oil price case, and 20% higher than in 22 in the high oil and gas resource case. Here I want to say that the world faces a potential global oil supply shortage over the coming decade. And the significant risk of a supply crunch in the oil market by 2025 and beyond, given the current pace of investment and the growth of world demand. The second problem of using synthetic polymers is the end life of these materials. Yeah, polymers derived from petroleum are considered as good candidates to be recycled. It is clear when we synthesize the polymers at the end life, we can recycle these materials and reuse it and give the second life of these materials. But after degradation, these polymers will, after degradation of these polymers, we obtain molecules or microplastics. And as particular features, certain bacteria must be able to hide inside and succeed in surviving and modifying ecosystems. Worse still, the Tara Oceans Foundation, it is the foundation which is situated in France, in Europe, reveals that 66% of the waste in rivers is microplastics. We throw until then that plastics fragmented at sea and under the effects of UV rays or waves. This plastic particle constitutes a new habit for many species of bacteria versus microalgae. Here I want to say that after degradation of synthetic polymers, which is coming from petroleum, is not biodegradable. Then after degradation, they form microplastics. And after raining, for example, this microplastic go to sea or ocean. And it's become as considered as habit for many species of bacteria and microalgae. And this bacteria or this microbe can be consumed by fish. And of course, the human is the first one who will be affected by this phenomena or this event by this pollution. I can see it is a pollution. What is the solution? Implementing biomaterials instead of synthetic materials and non-renewable resources that lead to pollution is becoming popular. Here I want to say, instead to use synthetic materials, we can use biomaterials, which is issue from natural resource. Their production can be carried out by using food processing industry, cellulosic and organic fraction of municipal waste, thereby developing a clean waste management system. Firstly, I want to say, what is the biopolymer? What is the difference between polymer and biopolymer, or between plastic and bioplastic? According to this paper, we can say biopolymers are polymers produced from natural sources, either chemically, synthetically, or from biological material, or actually biosynthesized by living organisms. We can give another definition, also given by this paper. Biopolymers are defined as polymers formed under natural conditions during the growth cycle of all organisms. Therefore, they are also named natural polymers because it is coming from a natural resource. They are formed within cells by complex metabolic process. For materials application, cellulose and starch are most interesting. Let's give short history of biopolymers. The first biopolymers discovered is rubber, also called India rubber, latex or caoutchouc, as initially produced. Consists of polymers of the organic compound isoprene with minor impurities of other organic compounds. It is discovered in the 18th century. We have another example, which is the casein. It is produced from raw milk. It is used, for example, to produce cheese. The third example is the cellulose, the material that makes up the cell walls of plants. It is obtained from plants. At the end of the 19th century and the beginning of the 20th century. So here, given these examples, I want to say that it is already used. The biopolymers are already used, but after that, after discover the petroleum, we start to synthesize polymer. But there is a problem because the world faces a potential global oil supply shortage over the coming decade. As you can see on this figure, we reach the peak in 19 years, and that starts to decrease. And maybe in 2050, we will not have the petroleum oil. So it was then followed in the bioplastic, which benefited from, which are well known today, like PLA, polyacid lactic, PHA, and also starches, with benefited from the rapid technical advancement in green chemistry and white chemistry, in recovery of biomass like starch, sugar, cellulose, etc. Therefore, significant attention has been paid to the improvement of those sustainable plastics directly derived from biomass overall performance to provide more than one advantageous property attributed to their versatility to be modified through chemical synthesis, copolymerization and surface modification, as well as through the use of different additives, micro and nanoparticle plasticizers, and active agents, among others. Several biobased polymers classified on the basis of their origin and obtainment process. Plastic can be obtained from biomass instead of petrochemical resource. These biomaterials are naturally derived polymers from plants and microbes. As you can see on this figure, we can obtain biopolymers based on three ways. The first one, polymers directly extracted or removed from biomass polysaccharides, for example, starch and cellulose, protein, for example, casein and gluten. The second way polymers obtained with the help of microorganisms and genetically modified bacteria. The main representatives of this group are polyhydroxyalkanoate or PHA. The third one, polymers made by classical chemical synthesis using monomers from renewable resources. Here I want to say that we do the synthesis of polymers, but the monomers is obtained from renewable resource. A good example for this category is polylactic or polyacid lactic, which is a biopolyester formed by polymerization of monomers like lactic acid. Okay, I will give you some examples of how to obtain biopolymers from nature. The first one is, according to this journal, the first one is the extraction of chitin and chitosan. So chitin is a biopolymer which can be obtained from shrimp, for example. The raw materials were obtained in kilogram from the different sources. After that, it is washed with water, desiccated at room temperature, and cut in small pieces. Then the first step is the demineralization. This step was carried out at room temperature using hydrochloric acid baths. Here I have to say that the number of baths and their duration will depend upon the source. It was observed that the emission of CO2 gas, of course, it is the elimination of mineral materials. That's why there will be the emission of CO2 gas was more and less important, indicating or according to the study species. Here I mean, for example, when we use crabs or shrimp of Kelvin, we will obtain a higher quantity of CO2, but it will be weak in case of one kind or when you use another source. The second step after demineralization is deproteination. Here we will remove the protein from this material. It was performed using alkaline treatment with sodium hydroxide solution. This treatment was repeated several times as well. The number of baths depend on clarity of the solution. Here we will eliminate the color. So we will do this step many times until the color disperses. When we have the absence of color of the medium at the end of the last treatment, then we will proceed to washing with the distilled water. Was then carried out up to neutrality, after which the samples were dried. At this stage, pigments responsible for the color are removed using mild oxiding treatment. In ethanol was also used to eliminate trace of protein and coloring materials. At these steps, we will obtain only chitin, which is a biopolymer, and it is very used in, for example, as additive in food. In order to obtain another biopolymer, which is chitosan, we have to do the last step, which is the acetylation. using, of course, sodium hydroxide. Here, for example, as you can see, we have this groupment. After desacetylation using sodium hydroxide, we can remove this group in order to obtain a ketosane. Here, after extraction, we can obtain only ketene. If we need to obtain another or the second biopolymer, we have to do this last step, which is the acetylation using hydroxide, sodium hydroxide, by removing this group. Okay, the second example is the extraction of cellulose. Cellulose also is a biopolymer. According to this paper, the isolation of cellulose or the extraction of cellulose occurs in two stages. The first one is a pretreatment of the plant, the complete or partial removal of hemicellulose and lignin. Hemicellulose and lignin are also biopolymers which are linked with cellulose. That's why we have to remove these biopolymers, hemicellulose and lignin, in order to obtain or extract cellulose. And or isolation or the isolation of the cellulose fiber. The second step is controlled chemical treatment to remove the amorphous region of the cellulose polymer, because cellulose has crystalline region and amorphous region, and it is more interesting to remove amorphous region and let only a crystalline region. So the first step is the purification of plant to obtain pure crystalline fraction from the pretreatment of the selected natural fibers. Fibers first washed with the distilled water several times, dried and chopped. Fats, wax, and oil is removed from the skein powder, simple by reflexing on Soxley apparatus for 24 hours with acetone ethylene mixture. Then we proceed to the second step, which is the alkaline treatment. Here in this step, the fibers are then treated with sodium hydroxide solution. This treatment was done 5 times to remove constituent difference than cellulose from the fiber. The constituents different than cellulose, as I said, it is hemicellulose and lignin. This removed the greater part of lignin and a large part of hemicellulose. After each treatment, the fibers were filtered and washed with distilled water until the alkali was removed. Here I want to say that pH will be reach 7. Then we proceed to the third steps. It is the bleaching of the fiber, because we have to obtain a white color of cellulose. And because of persistent coloration, the product is bleached with sodium chloride mixed with glacial acetic acid mixture to remove any residual lignin and hemicellulose that may still be in solution. Bleaching treatment is carried out to bleach the fiber. Then it is filtered and washed with distilled water. The last step, which is acid hydrolysis, as I said, we have to remove the amorphous region. And hydrolysis was carried out with the sulfuric acid to remove the no crystalline regions, leaving a collection of well-dispersed microfibers. Here we can add, according to this paper, we can add the 5th step if we want, because at this 4th step we will obtain fibers, microfibers. If we want to obtain nano whiskers or nanofibers, we have to complete this 4th by 5th steps, which is sonification. Sonification can be help us to obtain nanosquare of fibers. Okay. Until then, natural fiber, as we can see, the natural fibers are particularly important to preserve the environment and limit fossil resource, which is the petrol or oil using. Nevertheless, the textile industry and agriculture residue raise a significant amount of waste fiber. Here I show you this figure at the right. As we can see, when, for example, we produce rice, we have 90% of waste. We generate waste. This waste is very rich or contain three polymers, biopolymers, which are lignin, hemicellulose, and cellulose. This waste can be used as renewable energy. It can be used as animal feed. It can be used as textile fibers. But my idea here it is to use it as biodegradable plastics, to produce or to extract biodegradable plastics. So it is therefore extremely important to expand a new process to use and rationally employ these resources. Here are some examples of natural resource in order to obtain biopolymers. Okay, I give you the first example, the rice straw. Rice is among the oldest cultivated crops and the most widely grown food grain crop, and it is the staple food for 60% of the India population. I think, I hope it is true information. And India is the second rice producing nation. In India, rice can be grown at altitude of over 300 meters from sea level and 3 meters below sea level. There are millions tons of straw waste annually after the crop, and it is intended to be burning and cattle feed. Each kilogram, listen here, each kilogram of milled rice leaves about 1.4 kilogram of rice straw byproducts. Here I want to say that the byproducts or the waste, the quantity of byproducts or the quantity of waste is higher than rice during harvesting. These are considered agricultural waste. However, because it can be easily collected and it is cheap, it is possible to use this agricultural waste and residue to extract biopolymers, which is the cellulose, because this rice straw is very rich in three biopolymers, which are lignin, hemicellulose, and cellulose, mainly cellulose. Okay, the second example is waste coming from cotton processing. So cotton represents 46% of the world's production of fibers. The annual world production of cotton was more than 25 million tons for the season 2019-2020. And the leading cotton producers is also India, followed by China and USA. Unfortunately, Africa as a continent delivers a total of 50 million tons of cotton. So cotton cropping involves warm, it needs a warm, humid climate and sandy soil. As you can see on the figure, we need between 80 and 110 days for planting and flowering to obtain the plant, as you can see in figure A. And we need between 55 to 80 days for the flower to produce the cotton ball, as you can see on figure B. According to chemical composition of cotton, we can, it is cellulose, the main compound is cellulose. We can extract 59% is cellulose. It is very rich in these biopolymers. So when we produce cotton, we can generate three main of waste. The first one is the remaining plant as farm waste, like stem, flowers, leaves, and stalks. The second waste is the impurities separated from the cotton fibers and recovered as processing byproducts. The third one is cottonseed. It is also proceed to recover cottonseed oils and cottonseed meals. Anyway, any waste generated from cotton crops can be also used to extract biopolymers, because it is very rich in cellulose, which is important biopolymers. Okay, as conclusions, what I can say, I would like to say that climate change and resource constraints, particularly for fossil fuels, have given renewed impetus to the development of plants for the sustainable synthesis of large spectrum of chemical and materials required by mankind. Although several novel polymers have been produced successfully in plants. Bioplastic simply refer to plastic made from plants or other biological material instead of petroleum. It is also often called bio-based plastic. As we could see, bioproducts produced like raw rice, cotton fiber, and agro waste and animal fiber waste from the food industry, like seafood, are common natural fibers. It is welcoming to see the benefit of use natural fiber byproducts to obtain biopolymers. Here I want to say that instead to use natural fibers, it is more interesting if we use the bioproducts to obtain these biopolymers. Not only we will reuse this bioproduct, it is good for our environment, and we give the second life to this waste. In the end, environmentally friendly biopolymer from bioproducts will be the materials for the near future, not only as a solution to growing environmental threat, but also as a solution to elevate the uncertainty of oil supply. Like this, I finish my presentation. Thank you to your attention. كي تقرا تبعنا راك صباح تبعنا راه مش نتعلم. Hello. Hello.
Hello.
Yeah.
Ma'am, thank you for such a wonderful
You are
talk.
not stupid.
Huh?
I thought that there is no one here.
No. We are here only. We are listening and we saw your presentation. Very good slides.
Thank you
You have
so much.
presented very well. And
Thank you so much.
students, if you have any questions, you can ask to ma'am. Hello. Okay. So many students, they are having a question like how to apply in Algeria for doing PhD.
We have to make exam. There is an exam every year, and we take, for example, each field we take 3 or 4 PhD students.
So,
for example, this
probably
year,
in this 2022, if these forms are out, you just share those forms with me. I will share with my students.
okay, why not? Okay, it will be, I think it will be on March, maybe. It is not sure, it is not showed until now, but it's depend of also it's depend on field. Okay, chemistry.
Okay, ma'am. Okay, so I don't think there are any more questions. So thank you very much again for such a wonderful talk and
Thank
guiding
you
our
for your
students in
invitation.
polymer.
It is my pleasure.
Thank you very much, ma'am.
Thank you, Masala.
Students, please leave the meeting now.